Close your eyes. Imagine total blackness. Now delete the blackness. Delete the empty space. Delete time. What's left? You can't do it. The human brain is literally incapable of imagining nothing. It is the most dangerous, powerful and misunderstood concept in history. A force that drove mathematicians insane and created the entire universe. Today, we are going to stare into that abyss. Before the Big Bang, there was no space to put anything in, and no time for anything to happen. There wasn't just empty darkness. There was absolute non-existence. And yet, from that mathematical impossibility, everything you have ever loved suddenly appeared. How does something come from nothing? To answer that, we have to ask the most difficult question in the world. What is nothing? Chapter 1. The Introduction. The Paradox of Definition. Try to imagine nothing. Not darkness, because darkness is still something. Not empty space, because space itself is something. Try to picture absolute nothingness. No matter, no energy, no space, not even time. Do you see it? Can you visualize it? Of course you can't. And here we encounter our first profound problem. The human mind cannot truly conceive of nothing. Every time we try to think about nothing, we inevitably think about something. We picture an empty room, a blank canvas, a dark void, but all of these are still something. The room still has walls. The canvas still exists. The void is still space. This is the paradox that will guide us through the next 2 hours. We are creatures of existence, born into a universe of things, and we are about to explore the one concept that defies our every intuition: nothingness itself. The linguistic trap. Let's begin with language, because the moment we try to talk about nothing, we run into immediate trouble. Consider this simple sentence. Nothing is in the box. What does this mean? It could mean that the box contains nothing, that it's empty. But grammatically, it could also mean that there is something called nothing, and that thing is located in the box. The word nothing becomes a noun, a thing, the very opposite of what it's supposed to represent. Here's an even more confusing example that philosophers love to debate. Nothing is better than eternal happiness. Most of us would agree with that statement. Eternal happiness is the ultimate good, and nothing surpasses it. But now consider this second statement. A ham sandwich is better than nothing. This also seems true. If you're hungry, you'd prefer a ham sandwich to having nothing at all. But if we follow the logic through, we arrive at an absurd conclusion. If nothing is better than eternal happiness, and a ham sandwich is better than nothing, then a ham sandwich must be better than eternal happiness. Obviously, this is ridiculous, but it shows us how slippery the concept of nothing becomes the moment we try to capture it in words. The ancient Greek philosopher Parmenides understood this problem 2,500 years ago. He argued that we cannot even speak of nothing, because the moment we name it, the moment we discuss it, we give it existence. To say nothing exists is a contradiction, because you've just claimed that something called nothing exists. This linguistic trap has haunted philosophers, mathematicians, and scientists for millennia. The three types of nothing. But let's try to be more precise. Philosophers have actually identified three distinct types of nothing, and understanding these categories will help us navigate the rest of our journey. The first type is called nihil privativum, which means privative nothing in Latin. This is the absence of something in a place where something could be. Think of an empty cup. The cup exists, the space inside the cup exists, but there's no water in it. The nothingness here is relative. It's the absence of a particular thing in a particular context. When you say there's nothing in the refrigerator, you don't mean the refrigerator has ceased to exist, or that it contains a complete vacuum. You mean it lacks food. This is the nothing of everyday life, the nothing we encounter constantly. It's not truly nothing, it's just the absence of what we expected or wanted to find. The second type is nihil negativum, or negative nothing. This is logical impossibility. Imagine a square circle. Can you picture it? No, because the very definition of a square contradicts the definition of a circle. A square circle cannot exist, not because we haven't found one yet, but because the concept itself is incoherent. It's nothing in a logical sense. Similarly, think of a married bachelor. The moment someone gets married, they are no longer a bachelor. These concepts negate themselves. They represent a nothing that cannot ever become something because they violate the basic laws of logic. The third type is the most mysterious and the most terrifying. Absolute nothingness. This is the complete absence of everything. No matter, no energy, no space, no time, no laws of physics, no possibilities, no potential. This is the nothing that might have existed before the Big Bang, if before even makes sense in that context. This is the nothing that philosophers lie awake contemplating. This is the nothing we will spend most of our time exploring, because this is the nothing that challenges everything we think we understand about existence itself. There's a reason this topic unsettles us. Humans have an actual phobia of emptiness and voids, called canophobia. We fill our silences with noise, our empty walls with pictures, our free time with activities. We seem desperate to avoid confronting emptiness. Throughout history, nature was said to abhor a vacuum. We've always sensed that nothing is somehow wrong, somehow threatening. But here's what makes this journey so fascinating. Nothing might be the most important concept in all of human knowledge. Without the invention of zero, we wouldn't have modern mathematics or computers. Without understanding the void, we wouldn't have discovered the structure of atoms or the origin of the universe. Without contemplating nothingness, we might never have developed some of our deepest philosophical and spiritual insights. Over the next 2 hours, we're going to journey through 4 realms. We'll start with mathematics and see how humanity learned to calculate with nothing. We'll move into philosophy and discover how different cultures have understood the void. We'll dive into physics and learn that empty space is far stranger than we ever imagined. And finally, we'll peer into the ultimate future and see how everything might return to nothing. By the end, you'll never think about nothing the same way again. Chapter 2. The History of Zero. Nothing in mathematics. Let's travel back to ancient Greece. Around 500 BCE, the Pythagoreans, followers of the famous mathematician Pythagoras, believed that all of reality could be explained by numbers and their relationships. To them, the universe was fundamentally mathematical. Numbers were sacred, divine, the language of the cosmos itself. But there was one number they absolutely refused to accept: 0. Why? Because 0 represented nothingness, and to the Greeks, nothingness was philosophically impossible. The great philosopher Aristotle argued that nature abhors a vacuum, that it was impossible for empty space to exist. He reasoned that if you had a true void, truly empty space, then there would be nothing to resist motion. An object moving through nothing would move infinitely fast, which seemed absurd. Therefore, Aristotle concluded a vacuum cannot exist. The universe must be completely full, a plenum with no gaps anywhere. This wasn't just abstract philosophy. This belief shaped how the Greeks did mathematics. They could count 1 sheep, 2 sheep, 3 sheep. But how do you count 0 sheep? If there are no sheep, what are you counting? The absence of sheep isn't a number, it's nothing at all. So, while the Greeks made extraordinary advances in geometry and mathematics, they did it all without a 0. They had no symbol for it, no concept for it, no place for it in their number system. The Greek mathematician Zeno, around 450 BCE, created a series of paradoxes that seemed to prove that motion itself was impossible, all related to concepts of infinity and nothingness. The most famous is the paradox of Achilles and the tortoise. Imagine Achilles, the great warrior and fastest runner, racing against a tortoise. Being a good sport, Achilles gives the tortoise a head start. Now, Zeno argued, Achilles can never overtake the tortoise. Why? Because first, Achilles must reach the point where the tortoise started. But by the time Achilles gets there, the tortoise has moved a bit further ahead. Now Achilles must reach that new point. But again, by the time he arrives, the tortoise has moved a little more. This continues infinitely. Achilles gets closer and closer, but he must always cover half the remaining distance, then half of what remains, then half again, infinitely many steps. How can you complete an infinite number of steps? Zeno concluded, you can't. Motion is an illusion. Of course, we know Achilles would easily pass the tortoise in real life, but Zeno's paradox revealed something deep. The Greeks had no mathematical tools to deal with infinitely small quantities, with things approaching 0. They couldn't handle the mathematics of continuous change. And this limitation held back Western mathematics for centuries. The Greeks were so brilliant, yet this blind spot about nothingness constrained what they could discover. The birth of 0. Now let's shift our attention eastward, to ancient Mesopotamia, around 300 BCE. The Babylonians used a number system based on 60, which is why we still have 60 seconds in a minute and 60 minutes in an hour. They wrote numbers using wedge-shaped marks in clay tablets, but they ran into a problem. How do you write the number 305? It's 3 60s, no ones from the next level, and 5 ones. Without some way to show that gap, how do you distinguish 305 from 35. The Babylonians invented a placeholder symbol, 2 small wedge marks that meant there's nothing here in this position. This wasn't 0 as a number. You couldn't calculate with it. It was more like a blank space in writing, a way to say, skip this spot. But it was the first step toward our modern concept of 0. The true revolution happened in India around the 5th century CE. A brilliant mathematician and astronomer named Brahmagupta did something extraordinary. He declared that 0 wasn't just a placeholder, but a number itself. You could add it, subtract it, multiply it. He wrote down rules for working with 0. 0 plus any number gives you that number. Any number minus itself equals 0. Any number times 0 equals 0. These might seem obvious to us now, but at the time they were revolutionary. But Brahmagupta went even further. He explored what happens when you divide by 0, and here he encountered deep mystery. He reasoned that a positive number divided by 0 should be infinitely large, and he called this concept kahara, which translates roughly as quantity with 0 as denominator. He was grasping toward the concept of infinity, the idea that some quantities can grow without bound. Modern mathematicians say that division by 0 is undefined, that it doesn't produce infinity, but rather breaks mathematics itself. But Brahmagupta was brave enough to explore this dangerous territory. The Indian concept of 0 was intimately connected to their philosophy. In Sanskrit, the word for 0 is shunya, which also means empty, void, or blank. In Hindu and Buddhist thought, the void isn't something to be feared. It's the source of all potential, the pregnant emptiness from which everything arises. When Indian mathematicians worked with 0, they weren't just manipulating an abstract symbol. They were engaging with a deep spiritual concept about the nature of reality itself. Around 825 CE, a Persian mathematician named Al-Khwarizmi, working in Baghdad during the Islamic Golden Age, wrote a book explaining the Indian number system. This book eventually made its way to Europe, where it was translated into Latin. Al-Khwarizmi's name would eventually be corrupted into the word algorithm, and his book's title, which referenced al-jabr, or restoration, would give us the word algebra. The Indian numbers, including 0, slowly spread through the Islamic world and into Europe. But even in Europe, 0 faced resistance. Some people thought it was dangerous, even demonic. How could nothing be something? Some merchants banned its use because they worried it could be too easily altered. A 0 could be changed to a 6 or a 9, with just an extra stroke. In 1299, the city of Florence actually banned the use of 0 in accounting. They insisted on using Roman numerals instead, which had no 0. But you cannot stop an idea whose time has come. 0 was simply too useful. By the Renaissance, it had become indispensable. The power of the empty set. Fast forward to the 17th century. Isaac Newton in England and Gottfried Leibniz in Germany independently invented calculus, one of the most powerful tools in all of mathematics. And at the heart of calculus lies a profound engagement with nothingness. Here's the core idea. Imagine you want to find the slope of a curve at a single point. Slope usually requires 2 points. You calculate rise over run, the change in height divided by the change in horizontal distance. But at a single point, there is no change. The distance between the point and itself is 0. You end up trying to calculate 0 divided by 0, which is meaningless. Yet somehow calculus finds a way around this. It uses infinitesimals, quantities that approach 0 without ever quite reaching it. You find the slope between 2 points that are very close together. Then imagine bringing those points closer and closer together, letting the distance between them shrink towards 0. The slope approaches a specific value, and we call that value the derivative. Calculus performs this magic trick of working with nothing without ever quite touching it. It dances around 0, uses its power, but never falls into the logical abyss. This mathematical sleight of hand opened up the entire modern world. Engineering, physics, economics, biology, nearly every scientific field relies on calculus. And calculus relies on our ability to work with quantities that approach nothingness. Then, in the late 19th century, a German mathematician named Georg Cantor developed set theory, a way of thinking about collections of objects that would become the foundation of all modern mathematics. Cantor asked a strange question: what is the most basic set possible? And he answered, the empty set, the set that contains nothing at all. He gave it a symbol that looks like a circle with a line through it. Now, here's where it gets truly mind-bending. Cantor showed that you can build all of mathematics starting from nothing. You begin with the empty set, the set containing 0 elements. Then you create a new set that contains the empty set. This new set contains 1 element, even though that element is itself nothing. Now you have something to count. 1. Then you create a set containing both the empty set and the set containing the empty set. Now you have 2. You can continue this process forever, generating all the counting numbers from nothing but the empty set. In other words, all of mathematics, all of number theory, geometry, algebra, everything can be constructed starting from pure nothingness. This is perhaps the most profound discovery about nothing in all of mathematics. Nothing is not the absence of something. Nothing is the foundation of everything. 0 isn't just a number among numbers. It's the number that makes all other numbers possible. The void isn't just empty space. It's the canvas on which all of existence is painted. Chapter 3. The Philosophical Abyss, Meaning and Non-Being Eastern Perspectives, the Fertile Void. Let's now leave the realm of mathematics and enter the realm of meaning. How have human beings understood nothingness not as a calculation but as a fundamental aspect of reality itself? We'll discover that Eastern and Western philosophers have approached this question in radically different ways. In the ancient Hindu tradition, there is a concept called Brahman, the ultimate reality that underlies all of existence. Brahman is described in paradoxical terms. It is being and non-being, form and formlessness, everything and nothing simultaneously. The Hindu scriptures, the Upanishads, contain a famous teaching, neti neti, which means not this, not this. You cannot say what Brahman is, only what it is not. It is not this particular thing, not that particular thing. It transcends all categories, all distinctions. In a sense, Brahman is the ultimate nothingness. Yet from this nothingness, all things emerge. Think of it this way. Before a sculptor creates a statue, the stone contains infinite potential. It could become a human figure, an animal, an abstract form, anything. But the moment the sculptor makes the first cut, some possibilities are eliminated. As the work progresses, more and more potential is removed, until finally the statue is complete and all other possibilities are gone. In Hindu thought, the void is like that uncarved stone. It contains all possibilities because it is no particular thing. The universe emerges from this pregnant emptiness, this fertile void. In Buddhism, we find an even more radical embrace of nothingness. The Buddha taught about shunyata, usually translated as emptiness or voidness. But this is not emptiness as mere absence. It's a deep insight into the nature of reality itself. The Buddha taught that all things are empty of inherent existence. What does this mean? Look at a table. It seems solid, real, substantial. But the Buddha would ask, what makes it a table? The wood? But the wood came from a tree, and the tree came from a seed, and the seed came from another tree, and so on. The wood is not fundamentally table. It only becomes a table when a carpenter cuts it, shapes it, assembles it. And even then, it's only a table because we use it as a table. If we burn it for firewood, it's no longer a table. Everything about the table depends on other things: the tree, the carpenter, our concept of what a table is, our use of it. The table has no independent existence. It's empty of inherent being. It only exists as a node in a vast web of relationships. This sounds abstract, but it has profound implications. If everything is empty of inherent existence, then nothing has a fixed, unchanging essence. Everything is fluid, interconnected, constantly changing. The self you think you are is also empty. There is no unchanging soul, no permanent identity. What you call I is just a collection of changing physical and mental phenomena, constantly in flux. When you truly understand this emptiness, the Buddha taught, you are freed from suffering. You stop clinging to things that cannot last. You stop demanding that reality conform to your desires. You accept the flowing, empty nature of all things. The Heart Sutra, one of the most important Buddhist texts, contains a famous paradox. Form is emptiness, emptiness is form. The material world and the void are not separate. They are two ways of looking at the same reality. Everything is empty, and every emptiness has the potential to become form. This is not nihilism, not the claim that nothing matters. It's the opposite. It's the recognition that everything is interconnected, that emptiness and fullness are two sides of the same coin. In Taoism, another ancient Chinese philosophy, we find a similar appreciation for the power of emptiness. The Tao Te Ching, written by the sage Laozi around 2,500 years ago, contains beautiful passages about the utility of nothing. Laozi writes, 30 spokes share the wheel's hub. It is the center whole that makes it useful. He continues, shape clay into a vessel. It is the space within that makes it useful. Cut doors and windows for a room. It is the holes which make it useful. His point is profound. We focus on the material parts of things, but it's often the empty spaces that give them their function. A cup is useful because of the empty space inside that can hold liquid. A room is useful because of the empty space inside where we can live. A wheel works because of the hole in the center where the axle goes. In a sense, the nothing is more important than the something. This isn't just poetry. Laozi is making a philosophical claim about the nature of value and utility. We tend to think that more is better, that fullness is superior to emptiness. But often it's the opposite. Too much fills the space where possibility could exist. Too much noise drowns out meaningful sound. Too much activity prevents rest. Emptiness allows room for movement, growth, transformation. The Taoist sage cultivates emptiness, simplifies life, removes excess, and in doing so creates space for the Tao, the natural way of things, to flow freely. Western perspectives. The threat of non-being. Now let's journey westward to ancient Greece, where we find a very different attitude toward nothingness. Around 500 BCE, a philosopher named Parmenides made a startling claim. Nothing cannot exist. His reasoning was simple but powerful. To exist means to be. Nothing by definition is not being. Therefore, nothing cannot exist because existing means being, and nothing is the opposite of being. To say nothing exists is a logical contradiction. Parmenides took this further. He argued that change is impossible. Why? Because change requires something to come from nothing or become nothing. For an apple to rot, the fresh apple must cease to be, and something else must come into being. But if nothing cannot exist, then the fresh apple cannot become nothing. It must always have been what it is, and always will be what it is. Change, motion, birth, death, all illusions according to Parmenides. Only being exists, eternal and unchanging. Obviously, this contradicts our everyday experience. We see change everywhere. But Parmenides forced Western philosophy to grapple with a deep question. How can something come from nothing? This problem would haunt Western thought for millennia. The Christian tradition added another dimension to this question. In Genesis, God creates the world. But from what? The early church fathers developed a doctrine called creatio ex nihilo, creation out of nothing. Before God created the universe, there was nothing. No matter, no space, no time, nothing at all except God himself. And then God spoke, and something came into being where there had been nothing. This was theologically important because it emphasized God's absolute power. God didn't need any pre-existing materials to work with. He didn't shape the universe from primordial chaos like in some other ancient creation myths. He created it from absolute nothingness by sheer will. This made God's creative act completely unique and emphasized the complete dependence of creation on the Creator. But it also raised philosophical puzzles. If nothing existed before creation, where did the laws of physics come from? Where did space and time come from? How can something emerge from absolutely nothing? Some philosophers argued that God exists outside of time, that before creation doesn't even make sense because time itself was created. Others struggled to explain how the first moment of time could begin, since beginnings seem to require a prior time. In the 17th century, the German philosopher Gottfried Wilhelm Leibniz posed what he called the primordial question: why is there something rather than nothing? This question has been called the deepest question in all of philosophy. Think about it. Nothingness requires no explanation. Nothing is the default state. It makes perfect sense for nothing to exist because nothing has no causes, no complications, no mysteries. But the existence of something demands explanation. Why does the universe exist? Why do you exist? Why does anything exist at all? Leibniz believed that there must be a sufficient reason for everything, and the sufficient reason for the existence of the universe must be God. But even if you don't believe in God, the question remains. Physicists can explain how the universe evolved after the Big Bang. They can trace cosmic history back to fractions of a second after the beginning. But why was there a Big Bang at all? Why didn't nothing just continue being nothing forever? Some people find this question meaningless. They argue that existence is just a brute fact, something that requires no explanation. Others find it the most important question we can ask. The philosopher Martin Heidegger spent much of his career exploring what he called the question of being. Why are there beings at all instead of nothing? For Heidegger, this question opens up all of philosophy: existentialism and nihilism. In the 20th century, European philosophy took a dark turn inward, and nothingness became central to understanding human existence itself. The French philosopher Jean-Paul Sartre wrote a massive book called Being and Nothingness, and in it he argued that nothingness lies at the very heart of human consciousness. Here's Sartre's insight. Consciousness is always consciousness of something. When you're aware of objects, people, thoughts, feelings, always something beyond yourself. But consciousness itself is not a thing. It has no substance, no solid being. It's like a light that illuminates objects but is not itself an object. Sartre said that consciousness is a nothingness that exists. It's a gap, a distance, a separation between being and itself. Humans are unique because we can step back from ourselves, question ourselves, imagine ourselves being different. We are not simply what we are, like a rock is simply a rock. We exist at a distance from ourselves, and that distance is nothingness. This sounds abstract, but Sartre gives concrete examples. Imagine you arrive at a cafe to meet your friend Pierre. You scan the room, looking for him. Pierre is not at the first table. Pierre is not at the second table. Pierre is not at the third table. The entire cafe becomes a background of Pierre not being there. His absence is present to you. You experience nothing, but you experience it as a real absence. The nothing shows itself in your consciousness. Or imagine you're walking at night along a cliff edge. There's no railing. You become aware that you could throw yourself off. Nothing is stopping you. In fact, you are the nothing that separates you from doing so. You have complete freedom to jump or not jump. That freedom, that gap between you and your actions, is nothingness. It's terrifying because it means you are responsible for every choice you make. You cannot blame your nature, your past, or the situation. There's a nothing at your core that is pure freedom. Sartre believed this nothingness at the heart of human existence leads to anguish. We are condemned to be free, as he put it. We cannot escape the burden of choosing who we will be at every moment. And because there's no fixed human nature, no essence that determines what we should do, we must create our own meaning. This is existentialism. Existence precedes essence. We exist first, and then we make ourselves through our choices. But this radical freedom can lead to what Sartre called bad faith, when we pretend we're not free, when we hide from our nothingness. We tell ourselves, "I had no choice," or "that's just who I am," or "society made me do it." We try to become solid things, objects with fixed natures, because the nothingness of freedom is too heavy to bear. The German philosopher Friedrich Nietzsche had explored similar territory a generation earlier. Nietzsche is famous for declaring God is dead, by which he meant that European culture had lost its traditional source of meaning and values. The Christian framework that had given structure to life for 1,000 years was collapsing. And what rushed in to fill the void? Nothing. Nietzsche saw the approach of nihilism, the belief that life has no inherent meaning, no ultimate purpose, no objective values. Nietzsche warned that when people realize there's no cosmic meaning, no divine plan, no objective morality, many will fall into despair. They will experience the weightlessness of a life without foundations. He wrote, "When you gaze long into an abyss, the abyss also gazes into you." Confronting the void of meaninglessness can consume you. It can lead to depression, cynicism, or destruction. But Nietzsche didn't think nihilism was the end of the story. He believed humanity could overcome it by creating new values, by affirming life in spite of its meaninglessness. He envisioned what he called the Übermensch, the overman, who would have the strength to create meaning in a meaningless universe, to say yes to life, even though it contains suffering and ends in death. For Nietzsche, the greatest human achievement would be to dance joyfully over the void, to create beauty and meaning as a deliberate act of defiance against nothingness. Martin Heidegger, another German philosopher, explored the emotional experience of confronting nothingness, which he called anxiety or angst. Heidegger distinguished anxiety from fear. Fear has an object. You're afraid of a dog, a disease, a person. But anxiety has no object. It's a free-floating dread that arises when you confront the sheer fact of your existence, the groundlessness of being. You become aware that you exist, but you don't know why, that you will die, but you don't know when, that you must make choices, but have no ultimate guidance. Heidegger believed that most people spend their lives fleeing from this anxiety, losing themselves in the crowd, in routines, in entertainment, in busyness. We become the they, as Heidegger called it, living according to how one lives, doing what one does. believing what one believes. We avoid our individuality, our freedom, our mortality. But occasionally anxiety breaks through and we glimpse the nothing that underlies everything. These moments, though disturbing, are precious because they wake us up to authentic existence. All of these philosophers, Sartre, Nietzsche, Heidegger, recognized that nothingness isn't just an abstract concept. It's something we encounter in lived experience. The absence of meaning, the freedom to choose, the inevitability of death, the groundlessness of existence, these are not problems to be solved, but realities to be faced. And how we respond to the nothing at the heart of existence determines whether we live authentically or hide from ourselves. Chapter 4. The Scientific Void, Physics and Cosmology. The Classical Vacuum. Now let's move from the realm of meaning to the realm of measurement, from philosophy to physics. Scientists have discovered that nothingness is far stranger than anyone imagined. The empty void of space turns out to be one of the most interesting and mysterious things in the universe. Remember that Aristotle claimed nature abhors a vacuum. For 2,000 years, most people believed him. But in 1643, an Italian physicist named Evangelista Torricelli decided to test this claim. He took a glass tube about 1 meter long, sealed at one end, and filled it completely with mercury. Then he upended it, placing the open end in a dish of mercury. Some of the mercury flowed out of the tube into the dish, but not all of it. A column of mercury about 76 centimeters high remained in the tube, and above it was an empty space. What was in that space? Torricelli realized it was a vacuum, truly empty space. Air pressure pushing down on the mercury in the dish was supporting the column of mercury in the tube, and above the column there was nothing. No air, no ether, nothing. This was the first vacuum created on Earth in a laboratory. It proved that Aristotle was wrong. Nature doesn't abhor a vacuum at all. Empty space can exist. This might not sound revolutionary, but it transformed physics. If space could be empty, then objects could move through emptiness without resistance. Isaac Newton built his laws of motion and gravity on the assumption that space is a kind of empty container in which objects exist and move. Newton believed in what he called absolute space, a three-dimensional void that existed independently of the objects in it. Space was like an infinite empty room, and matter was like furniture placed in the room. The room existed whether furniture was in it or not. But in 1905 and 1915, Albert Einstein overthrew this conception entirely. Einstein showed that space is not separate from time, and neither is separate from matter and energy. Instead, space and time are unified into a four-dimensional fabric called space-time. And this fabric is not a passive backdrop, but an active participant in physics. Matter and energy curve space-time, and curved space-time tells matter and energy how to move. As the physicist John Wheeler later summarized, matter tells space-time how to curve, and space-time tells matter how to move. This means that truly empty space, space with absolutely nothing in it, is not a simple concept. If you remove all matter and energy from a region, does space still exist there? Einstein's equations say yes, space-time still exists, and it has properties. It can be flat or curved, expanding or contracting, vibrating with gravitational waves. In other words, even empty space in Einstein's universe is something, not nothing. The vacuum has structure. Quantum mechanics. Empty space is not empty. But Einstein's relativity wasn't the only revolution in 20th century physics. Around the same time, quantum mechanics was being developed, and it revealed that empty space is not empty at all. In fact, the quantum vacuum is seething with activity, one of the most bizarre and fascinating discoveries in all of science. It starts with Werner Heisenberg's uncertainty principle, formulated in 1927. Heisenberg showed that there are fundamental limits to what we can know about quantum systems. The more precisely you know a particle's position, the less precisely you can know its momentum, and vice versa. This isn't because our measuring instruments are crude. It's because, at the quantum level, particles don't have precise positions and momenta at the same time. These properties are fundamentally fuzzy, uncertain. Now, here's the strange part. This uncertainty applies to energy as well. Over very short time intervals, energy can fluctuate wildly. The vacuum, supposedly empty space, can briefly borrow energy from nothing, create particles and antiparticles, and then annihilate them back into nothing, all so quickly that the violation of energy conservation is undetectable. These are called virtual particles, and they're constantly popping in and out of existence everywhere in the universe. This sounds like science fiction, but it's experimentally verified. In 1948, a Dutch physicist named Hendrik Casimir predicted a strange effect. If you place two uncharged metal plates extremely close together in a vacuum, they should attract each other. Why? Because the vacuum between the plates contains virtual particles, but only virtual particles with wavelengths small enough to fit between the plates. Outside the plates, all wavelengths of virtual particles are present. This creates a pressure difference. There are more virtual particles pushing the plates together from the outside than pushing them apart from the inside. The plates should be squeezed together by nothing. This is called the Casimir effect, and it has been measured with extraordinary precision. The force is tiny, but it's real. Empty space, the vacuum, exerts a measurable push. Nothing pushes. This is not metaphorical. This is not philosophical. This is experimental physics. The vacuum has energy, structure, and effects. It is not nothing. Quantum field theory, our best description of fundamental physics, tells us that every point in space is filled with quantum fields. There's an electron field, a photon field, a quark field, fields for every type of particle. These fields permeate all of space. Even in a perfect vacuum, the fields are still there, vibrating in their ground state, their lowest energy state. And this ground state is not zero energy. It's a small but non-zero amount of energy at every point in space. Multiply this tiny energy by the infinite volume of the universe, and you get something deeply puzzling. Physicists call this the vacuum energy, or the cosmological constant problem. When you calculate how much energy the quantum vacuum should have, you get an answer that's absurdly large, perhaps 10 to the power of 120 times larger than what we observe. This is the worst prediction in the history of physics. Yet something like vacuum energy must exist, because astronomers have discovered that the expansion of the universe is accelerating. Some kind of energy is pushing space apart, and it seems to be coming from empty space itself. We call it dark energy, and it makes up about 68% of the total energy of the universe. The vacuum, the nothing between stars and galaxies, is actually the dominant component of reality. Think about that for a moment. The universe is mostly empty space. And that empty space is not empty. It's filled with invisible energy that's pushing the fabric of space-time apart, accelerating galaxies away from each other, determining the ultimate fate of the cosmos. Nothing is more important than anything. The origins of the universe. This brings us to perhaps the deepest question in all of science. Where did the universe come from? For most of human history, this question belonged to religion and philosophy. But in the 20th century, physics began to provide answers, and those answers bring us back to nothing. In 1929, Edwin Hubble discovered that distant galaxies are moving away from us. And the farther away they are, the faster they're receding. The universe is expanding. If you run this expansion backward in time, everything gets closer together, denser, hotter. About 13.8 billion years ago, all the matter and energy in the universe was compressed into an infinitesimally small, infinitely dense point. And then, in an event we call the Big Bang, space itself began expanding, carrying matter and energy with it. But here's a crucial point that's often misunderstood. The Big Bang was not an explosion in space. It was an explosion of space. Before the Big Bang, there was no space for an explosion to happen in. Space itself came into existence at that moment. And if space came into existence, and space-time is a unified thing, then time also came into existence. There was no before the Big Bang, because time itself began with the Big Bang. This makes the question, what caused the Big Bang, deeply problematic. Causation requires time. A cause comes before its effect. But if time itself began with the Big Bang, then nothing could cause it, because cause requires a before, and there was no before. We've reached the edge of physics, the boundary where our concepts break down. Some physicists argue that the Big Bang came from nothing, literally. In 2012, physicist Lawrence Krauss published a controversial book called A Universe from Nothing, in which he argued that quantum mechanics allows a universe to spontaneously appear from a quantum vacuum. Remember that quantum fluctuations can create particles from nothing. Krauss and others suggest that the entire universe might be the ultimate quantum fluctuation, an enormous statistical improbability that simply happened. Critics point out that the quantum vacuum, with its fields and its laws, is not really nothing its same. It's a something with very specific properties. Why does the quantum vacuum exist? Why does it have the properties it has? Why are there quantum fields at all? We've just pushed the question back one level. Philosopher David Albert argued that Krauss's nothing is not philosophical nothing, not absolute absence, but rather a quantum something. Other physicists have explored different ideas. Some suggest the universe is eternal, with no beginning at all, perhaps cycling through endless expansions and contractions. Others propose that our universe is one of countless universes in a vast multiverse, and that universes spontaneously pop into existence all the time from some kind of quantum foam. Each universe might have different physical laws, different constants of nature, and we happen to live in one that allows for stars, planets, and life. String theory, a speculative attempt to unify quantum mechanics and gravity, suggests that what we call the vacuum might actually be one of an enormous number of possible vacuum states, perhaps 10 to the power of 500 different possibilities. Our entire universe might be like a bubble in a vast ocean of other bubbles, each with different properties. And these bubbles might form spontaneously from a background state, a kind of vacuum. But all of these theories face the same ultimate question. Why is there a quantum vacuum, or a multiverse, or a string theory landscape, rather than absolutely nothing? Perhaps, as Leibniz thought, there must be some necessary being or principle that exists by its very nature and cannot not exist. Perhaps, as some physicists suggest, the laws of physics themselves are that necessary being, existing timelessly and giving rise to universes. Or perhaps, as others argue, we must simply accept existence as a brute fact, something that requires no explanation. There's another possibility, even more radical. Perhaps our question is wrong. Perhaps asking, why is there something rather than nothing, is like asking, what is north of the North Pole? It sounds like a sensible question, but it's actually meaningless. If time began with the Big Bang, then asking what came before is like asking what's north of the northernmost point on Earth. There is no north of the North Pole. Similarly, there might be no before the Big Bang, no outside the universe, no context in which the question of why the universe exists even makes sense. Another strange possibility emerges from quantum mechanics. Some interpretations suggest that before the Big Bang, the universe existed in a quantum superposition of all possible states, including existence and non-existence. The universe was in a state of being both something and nothing simultaneously. Only when the universe observed itself in some sense did it collapse into a definite state of existence. This sounds mystical, but it follows from taking quantum mechanics seriously at cosmic scales. The honest answer is that we don't know. We stand at the edge of knowledge, peering into the abyss of the ultimate origin, and we cannot see the bottom. We have pushed our understanding back to fractions of a second after the Big Bang. We can describe how the universe evolved from a hot, dense state to the vast cosmos we see today. But that first moment, that emergence from nothing or something like nothing, remains shrouded in mystery. Chapter: The Ultimate Fate, Nothingness in the Future, the heat death of the universe. We've explored where nothing came from and how something emerged from it. Now let's look forward into the deep future and ask, will everything return to nothing? The second law of thermodynamics tells us that entropy, the disorder in the universe, always increases. You can think of entropy as a measure of how spread out and evenly distributed energy is. A hot cup of coffee in a cold room has low entropy because the energy is concentrated in the coffee. Over time, the heat spreads out into the room, the coffee cools, and entropy increases. This process is irreversible. You never see a lukewarm cup of coffee spontaneously become hot by gathering heat from the surrounding air. Energy flows from concentrated to dispersed, from ordered to disordered, and this gives time its arrow, its direction. Now think about the entire universe. Stars are burning fuel, converting concentrated energy into dispersed radiation. Black holes are swallowing matter and energy. Galaxies are spreading apart due to the expansion of space. Every process in the universe is increasing total entropy. And this cannot continue forever. Eventually, in the unimaginably distant future, all the stars will burn out. All the black holes will evaporate due to Hawking radiation. All the matter will decay or be torn apart. The universe will approach a state of maximum entropy, where energy is perfectly evenly distributed, where no more work can be done, where no more change can occur. This is called the heat death of the universe, though it might better be called the cold death. The universe doesn't end in fire, but in ice, or rather in a uniformly lukewarm fog, approaching absolute zero temperature. In this state, nothing happens. There's still matter and energy, but it's spread so thin and so evenly that no structures can form, no life can exist, no thoughts can be thought. It's not absolute nothingness, but it's a kind of effective nothing, a universe where nothing of interest occurs for eternity. Physicists estimate this will take an incomprehensibly long time. Current stars will burn out in trillions of years. Brown dwarfs and red dwarfs might last for tens or hundreds of trillions of years. Black holes will take even longer to evaporate. The most massive black holes might persist for 10 to the power of 100 years. But eventually, even they will be gone. And then comes the black hole era, where the universe is dominated by black holes slowly evaporating. After that, the dark era, where even the black holes are gone and the universe contains only a thin soup of photons, leptons, and possibly dark matter particles, all moving away from each other as space expands. In this era, if you could somehow still exist, you might wait billions upon billions of years and never encounter another particle. You would be alone in an expanding emptiness. Eventually, the universe approaches what's sometimes called the Big Freeze or the Big Chill. The temperature everywhere approaches absolute zero. All organized structures have dissolved. The stars, galaxies, and black holes of our current era are forgotten ruins in an ocean of emptiness. The universe still exists, but in a sense, nothing exists in it. It has returned to a kind of nothing, not the absolute nothing before the Big Bang, but a practical nothing, an eternal silence. The concept of erasure. This raises a profound question that haunts modern physics. Is information ever truly lost? Can something become absolutely nothing? According to quantum mechanics, information is conserved. If you know the exact quantum state of a system now, You can in principle calculate what state it was in the past or will be in the future. The evolution of quantum systems is reversible, but black holes seem to violate this principle. When something falls into a black hole, all information about it seems to disappear. From the outside, you can't tell what fell in. A black hole made from collapsed stars looks the same as a black hole made from collapsed encyclopedias. The information seems to be destroyed, erased, turned into nothing. This is called the black hole information paradox, and it's troubled physicists for decades. Stephen Hawking initially argued that information is indeed lost in black holes, that something can truly become nothing. But this would mean quantum mechanics is wrong at a fundamental level, which seems unlikely. Later, Hawking changed his mind and argued that information must somehow be preserved, perhaps encoded on the surface of the black hole, the event horizon, in ways we don't yet understand. This debate connects to our deepest questions about nothing. Can anything truly cease to exist, or is existence conserved in some form? When you die, your body decomposes, but the atoms that made you up continue to exist. The information that was you, your memories, your personality, your consciousness, what happens to that? Does it simply end, turn to nothing? Or is it somehow preserved in the quantum states of the universe, encoded in correlations that will last until the end of time? Most physicists believe information cannot be destroyed, that the universe is deterministic at the quantum level, that everything that ever happened is in principle recoverable from the current state of the universe. But consciousness seems different. When you fall asleep, where does your consciousness go? When you die, where does it go? These questions have no clear scientific answers. Consciousness might simply be an activity of the brain, and when that activity stops, consciousness becomes nothing, truly ceases to exist. Or there might be something about subjective experience that we don't yet understand, something that cannot be reduced to physics alone. This is where science reaches its limit. We can describe the behavior of particles and fields, the evolution of the universe, the decay of black holes. But whether anything experiences that evolution, whether there is something it is like to be a conscious observer, and what happens to that something when the physical substrate fails, these questions hover at the boundary between physics and philosophy, between something and nothing. Chapter 6. Conclusion. The Essential Nothing. We've travelled through 2,500 years of human thought, from ancient Greece to quantum field theory, from Parmenides to the Big Bang, and everywhere we've looked, we've found nothing staring back at us. We discovered that mathematics is built on nothing, on the empty set, on zero, on quantities approaching the infinitesimal. We learned that Eastern philosophy embraces emptiness as the source of potential, while Western philosophy has struggled with the threat of non-being. We explored how physicists discovered that empty space is not empty, that the vacuum seethes with energy and virtual particles, that the universe itself might have emerged from nothing, or something indistinguishable from nothing. What's remarkable is how these different perspectives illuminate each other. The mathematical zero is not just an abstract symbol. It represents the same emptiness that Buddhists meditate on, the same void that quantum fields fluctuate in. The philosophical question of why there is something rather than nothing is not separate from the physics of vacuum energy and the Big Bang. The existential anxiety Heidegger described, the experience of confronting the groundlessness of being, connects to the quantum uncertainty at the heart of matter. Everything points toward nothing, and nothing gives rise to everything. We've seen that nothing is not merely the absence of something. Nothing is powerful, creative, essential. Without zero, we would have no mathematics. Without emptiness, we would have no room for possibility. Without the vacuum, we would have no quantum fields, no Casimir force, no dark energy. Without the void before the Big Bang, we would have no universe at all. Perhaps the deepest insight is this: nothing and something are not opposites, but partners in a cosmic dance. You cannot have something without nothing. Every form requires emptiness to exist in. Every particle requires space to exist in. Every moment of time requires a gap from the previous moment. Being and non-being define each other, create each other, depend on each other. The ancient Taoist symbol, the yin-yang, captures this beautifully. The black and white shapes flow into each other, neither complete without the other, each containing a seed of its opposite. This is not just poetry. This is the structure of reality itself. The quantum vacuum contains virtual particles that pop into existence and back into nothing. Space-time itself can curve so severely that it creates singularities, points where space and time cease to exist. The universe began in a state where everything and nothing were indistinguishable. We are, in a very real sense, the children of nothing. The atoms in your body were forged in stars, but the stars came from clouds of gas, and the gas came from the primordial plasma after the Big Bang, and the Big Bang came from, perhaps, nothing at all. You are something that emerged from nothing, something that will return to nothing, something that exists for a brief moment as a pattern of energy temporarily resisting the pull of entropy, the universal slide toward emptiness. But during your moment of existence, you can observe the universe, contemplate nothing, understand something. You can ask why anything exists. You can feel the vertigo of freedom, the weight of meaninglessness, the joy of creating meaning in spite of the void. You can calculate with zero, meditate on emptiness, measure the vacuum, and wonder at the Big Bang. You can write poetry about nothing, paint pictures of the void, make music in the silence. In the end, nothing might be the canvas, but we are the painting. We are the something that observes the nothing, the consciousness that lights up the void, the meaning that defies the meaningless, the temporary complexity that emerges from and will return to simplicity. We are the universe's way of contemplating itself, of asking about nothing, of transforming nothing into something for a little while, and perhaps that's enough. Perhaps that's everything. The void awaits, patient and eternal. But for now, we exist. For now, we can wonder. For now, we can think about nothing. And in thinking about nothing, create something beautiful.